Hello and welcome to the chemistry course for Edexcel GCSE. My name is Elspie and I will be taking you through this course. Just a few bits of general information. Like I said, this is the Edexcel IGCSE Chemistry course and we follow the following textbook for our lessons, so I suggest that you have this on hand. Once you buy the book, you will see that there is an option for an electronic version of the book, which might be easier for some, but for all of our lessons you need to ensure that you have this book with you, and I will, as we go along, share what pages we're looking at. If you have any additional questions about the lesson or any of the content, please feel free to email drclaire@nationaltutors.co.uk, or you can make use of the messaging facility on the website. Okay. Just a general overview of how the lessons will work. Each of the lessons will clearly state the page numbers of the relevant sections in the textbook that we're looking at, and at the start of the lesson I will indicate that the topic covered is for chemistry only. If I don't say anything, then you know that that's for everyone, relevant for everyone. Each of the lessons will include lots of detailed explanations and examples, and I will walk you through all the concepts. We will do some guided practice where I show you how to approach different tasks, and then there will be time for you to do some individual tasks as well, and we will work our way to working through some exam questions as well. So for this lesson we are looking at page 2 to 13 of the textbook. You should have a notebook with you. You should also have some pens and some highlighters. I suggest you use the same notebook every time you do a chemistry lesson. Add a date and a title, so that will help keep things nice and orderly. Throughout the lesson, when you feel there's something that you want to write down, please just pause the video, or you can always go back to listen to something again if you didn't quite catch it. When we get to the tasks, I will ask you to pause the video so that you can have some time to do the task on your own before I go through the answers with you. Okay, so our first topic that we're going to look at is Unit 1, the Principles of Chemistry. The first section in that is states of matter. Okay, so you might be familiar with the different states of matter. We have 3 states of matter. We have a solid, a liquid, and a gas. And on the screen you can see the diagram for one of those. So I want you to take a minute and have a look and think if you can identify which of the 3 states that might be. And also think about how you would show the particles in the other 2 states that is not shown. So if you want to pause the video right here and make a quick drawing of the particles in the 3 states. Okay, so you should have identified that the state of matter on the screen is a gas, and if you had a chance to draw the other 2 states of matter, that is what they should look like. So we're going to take a look at each of these individually. You can clearly see the first slide, the first diagram, which is the solid, this one here. The particles are arranged in a very specific pattern. They're very close to each other, they're very densely packed, and they have a very regular pattern. So, I mean, they're in rows. Okay, if we take a look at the second one, which is the liquid, this one here, we can see that there's no regular arrangement. The particles are almost all over the place, and we can see that the particles are sliding over each other. And then in our third one, the one that we started with, we can see there's a lot of space in between the different particles. So we can see that there's lots of space and there's no regular arrangement whatsoever. Okay. So like I said before, the particles in a solid will always be arranged very regularly. Okay, and this means that it's arranged in a very specific pattern called a lattice, where they form basically rows. Okay, so these particles are packed really, really close together, and they have some really strong forces of attraction between them, keeping them in that fashion. Now, the particles in a solid cannot move freely. They can only vibrate around fixed positions. So that sort of means the particles can stay where they are, but they can vibrate around a little bit. And as they gain energy, they're going to vibrate more and more and more. Now, a common mistake that students make is that they think a particle on its own can have a state of matter. Now, this is not true. We determine the state of matter of a substance with regards to its relation to the other particles in that substance. So we can see that in the substance on the screen, all of the particles are arranged in a regular fashion. They are close together, therefore we know that that represents a solid. But a single particle on its own cannot have the property of a solid, a liquid, or a gas. It has to be the combined effect of all the different particles together. Okay, so if you want to write down any of these notes, you are welcome to do that. Otherwise, we will move on to the next one. So next up is liquids. So as we can see from the diagram, most of the particles are touching, and there are some gaps. So it's a little bit different to that from the solid. And because of these gaps that's now introduced between the liquid particles, we know that liquids are usually less dense than solids. So because solids are so very closely packed, they usually have a higher density. I say usually because if we think about water, if you have solid water, which is ice, we know that ice floats on water. So solid water, ice, can float. So ice is less dense than water. And this is not true for all liquids. Liquids are usually less dense than solid, but water is the exception to this rule. Now, in a liquid, the forces between the particles are less strong. Therefore, the particles can actually move around. And one of the properties of a liquid is the fact that it can flow. So these particles can flow over each other and they move around. So they have a little bit more energy than the particles in a solid. These particles are arranged very randomly. There's no real pattern. They're not in a nice little row. So that is the particles in a liquid. Once again, if there's anything that you want to add or annotate on your diagram, feel free to pause the video before you move along. Right, the third state of matter, gases. In a gas, the particles are very far apart, and that means that the force of attraction between the particles there's very little forces of attraction between the particles. The particles in a gas have the most kinetic energy. Now, you will remember the kinetic energy is the energy of movement. So gases have the most kinetic energy, the particles, which means they will move around the most. Liquids have less kinetic energy than gases, and solids has the least amount of gases compared to all of them. Okay, so we can see that the particles are quite far apart, and the particles in a gas will move randomly, and they move at quite a high speed, and they will move in all sorts of different directions, bumping into the side of the container and so forth. Okay, so that's the basic principles of the particles in a solid, a liquid, and a gas. So I have a task for you. So I would like you to answer the 3 questions on the screen. You can pause the video and have a chance to answer this in your notebook. You can just write the answer, and then once you're ready, you can come back and I will look at the answers with you. Okay, so if you've had a chance to answer the questions, let's take a look at what you've said. So the first question, name the state of matter where particles can only vibrate around a fixed position. That is a solid. Well done if you got that correct. Our second question, name the state of matter where particles can flow over each other. This is a little bit of a trick question because we can have both liquid or a gas here, but I'm assuming most of you said liquid. And then the state of matter that has the most kinetic energy is a gas. Okay, so well done to you if you got that correct. If you did not manage to answer all the questions correctly, just take a minute and perhaps go over the previous slides before you move on. Right. Okay, so what we're going to do now is we're going to take a look at the interconversions between the different states of matter. So if we take water, for example, we know that water can be heated up and it will eventually turn into water vapor. We also know that we can freeze water and it will turn into solid ice. So that is what we're talking about, the interconversions. So first of all, let's see if you can identify the different states of matter represented by the diagram on the screen. So what we have here is we have a solid, we have a liquid, and we have a gas. Okay, and we are going to take a look at the different processes involved in changing between these states. So the first change of state that we're going to take a look at is between when we change from a solid to a liquid. Okay, changing from a solid to a liquid is called melting. And this is the process that requires energy. So if you want a substance to melt, to change from a solid to a liquid, you have to heat it up. So energy needs to be put in, and then it will change state. So what will happen is the solid particles will gain energy. They will start vibrating more and more and more. Eventually, they will have so much energy or enough energy to start breaking the bonds that's keeping them in this solid pattern that we see. And then the particles will start moving around a little bit more, and then it will change into a liquid. Now, this happens at a very specific temperature, and we call that temperature the melting point. Okay, so the melting point is the temperature at which the solid will turn into a liquid. Okay. Now we can also take a look at the reverse reaction, where the liquid turns back into a solid. Okay, so when we have a liquid turning into a solid, we call that freezing. In this case, instead of adding the energy is taken out. So you're cooling something. Okay, so if we want to make ice, we put the water in the freezer, energy is removed from it, it cools down, and then it turns into a solid. So what happens to the particles, they lose energy, and because they lose energy, they move less and less and less, and eventually they will start to fall back into that regular pattern that we now know a solid is. Now, this also happens at a very specific temperature, and we call that the freezing point. So we have the melting point and we have the freezing point. Now, what is really interesting is the melting point and the freezing point of substances are exactly the same. Now, this can be quite confusing for students. So let's just take a look at water. Pure water has a melting point and a freezing point of 0 degrees Celsius. That means if I heat up water or solid ice to a temperature of 0 degrees, it will start melting. And if I cool down water in the liquid form down to 0 degrees, it will start freezing. So the melting and the freezing point is the same, depending on whether energy is added or taken away will determine which direction it's going to go, whether it's going to turn into a solid or whether it's going to turn into a liquid. Okay, so that is change of state between liquid and a solid. Okay, so let's have a look at the change of state between a liquid and a gas. So a liquid to a gas. This is once again a change of state where energy is put in the form of heat. So something is heated up and then the liquid particles will gain enough energy so that they can overcome the forces that keeps them as a liquid. The particles will start moving more and more and more, and then eventually we will have a gas. Now there's two ways in which particles can, or a substance can change from a liquid to a gas. The first one is boiling, and the second one is evaporation. Now, even though both of these processes have exactly the same end result, the process itself is slightly different. Now, boiling happens at a very specific temperature, and we call that our boiling point. So when we boil a liquid, it means that the particles is heated quite strongly and they reach a very specific point where they start changing into a different state of matter. If you take a look at water boiling, so for example, you look at a pot on the stove with some water in or on the hob, you will see bubbles forming. And that is because some of the particles in the liquid is turning into a gas. So that's why we start seeing these bubbles forming. And we can see that this happens through the entire liquid. So this happens at a very specific temperature. So for example, for pure water, we have a boiling point of about 100 degrees Celsius, and that's the temperature at which water will boil. Now, when we take a look at evaporation, evaporation does not happen at a very specific temperature. It happens over a range of temperatures. And we can see this when we think of water that's been spilled on the floor, for example. You know that if you leave it for a little while, eventually it will dry up. And we definitely know that the temperature outside is not 100 degrees. Therefore, evaporation happens over a range of temperatures. Now, unlike boiling, where the particles all throughout the liquid will start gaining lots of energy, with evaporation, the particles on the surface of the liquid will gain enough energy first, and that will then escape, and then the next bunch of particles will then start gaining energy and evaporate. So the faster moving particles will escape from the surface of the liquid, and that will then form a gas. So that is the main differences between boiling and evaporation. Right, if we take a look at the opposite change of state, going from a gas to a liquid, This is once again a process where we remove energy, or we remove the heat. So we're cooling it down, and we call this process condensation. Okay, so that is our changing of states between a liquid and gas and a gas and a liquid. Okay, so if you take a look at the diagram or the picture on the screen, you can see that we have a picture of dry ice, which you might be familiar with. Now, dry ice is not actually ice at all. It is carbon dioxide in a solid state. Now, carbon dioxide has such a low melting and boiling point that it skips the liquid state altogether, and when it's at room temperature, it will change directly from a solid into a gas. So that conversion that we have from a solid directly into a gas is a process called sublimation. We can also have the reverse of this process, where a gas will directly turn into a solid, and we call this process deposition. Some people might also refer to it as simply sublimation. Okay, we're going to do a quick exercise to see if you can identify what state of matter substances will be if I give you its melting or boiling point. So we'll do guided practice on the first one, and then I have 2 examples for you to try. So the first one, if you take a look at the thermometer on the screen, you can see that the thermometer is currently at about 20 degrees Celsius. I tell you that the substance has a boiling point of 45 degrees Celsius, and it has a melting point of 5 degrees Celsius. I want you to tell me what state of matter it will be if it is at 20 degrees Celsius, like we see here. Okay, so what you have to think about is, has it reached its boiling point, or has it reached its melting point yet? So if a substance melting point is at 5 degrees, that means anything below 5 degrees will be a solid. If the boiling point is 45, it means that anything above 45 degrees, it will be a gas. If it's anywhere in between 45 and 5 degrees, it will be a liquid. So if we take a look at this example, where we have our substance on the thermometer, we can see that it's 20 degrees Celsius. That's between the boiling point and the melting point, which means it's not reached the boiling point yet. Therefore, this substance will be a liquid. Now, let's try an example on your own. Right, so you can pause the video here and have a minute to think about what state of matter, solid, liquid, or gas, this substance will be. And then once you're ready, you can play and I will talk you through the answer. Okay, so now that you've had a chance to look at that, we can see that this substance has a melting point of 0 degrees Celsius, and it has a boiling point of 100 degrees Celsius. Therefore, anywhere between 0 and 100 degrees will mean it's a liquid. Anything below 0 degrees will be a solid, and anything above 100 degrees will be a gas. If we take a look at our thermometer, it's at 20 degrees, which places it between the melting point and the boiling point. Therefore, that is a liquid. So well done if you got that correct. Right, I have another one like this for you to try. So once again, just pause the video for a second and see if you can answer this question. Okay, if you had a chance to look at this, we can see that in this question we have a substance with a boiling point of 60 degrees and a melting point of 20 degrees. That means anything above 60 degrees will be gas, and anything below 20 degrees will be a solid. Anything between 20 and 60 degrees will be a liquid. So looking at the thermometer, we can see that the substance is at 0 degrees Celsius. Therefore, we can say that we know that this substance is currently a solid. So once again, well done if you got that correct. So that brings us to the end of our first session. What I would like you to do now is if you could answer questions 1 to 3 on page 12, and we will go over these questions at the start of our next session. So answer the questions on page 12, question 1, 2, and 3, and then at the start of our next session I will go through the questions and the answers with you. If you have any questions, please remember to send an email to Dr. Claire or use the messenger service on the website. See you next time.